Good afternoon, students. This is video 1.11. This is geometric tools, and your objective is I can identify rigid motion transformations. So let's go, flippers. A rigid motion transformation is a transformation that preserves distance, so that's a very important word, and angle measures of a figure. The mappings of the figure changes its location and orientation, so two more important words, location and orientation, but the pre-image and the image are congruent. Okay, so let's look at an example of what rigid motion transformations look like. And here's one here. So if we look at this picture, what we're looking at is two different figures. Over here we have the pre-image, and over here we have the image. So this is the image, the pre and the image. Okay, so now let's actually investigate and kind of look at what the definition of rigid motion transformation means and how we can apply that to this example. So if we look at our example, we have two figures very clearly, and these two figures are congruent. If we were to measure the area inside of them, it would be the same. And more importantly, if we look at the mappings of these actual figures, we'll see that they are also congruent. So let's look at point A. So here's point A. Let's figure out where that point is. It appears that point A is at 2, 4 over 2 up 4. And let's figure out where A prime is. And that's how you're going to read the image. The image. That is a prime marking right there. The little dash thing. So we're going to call it A prime. So let's figure out where that is. And A prime is at -5, 1. So these are the coordinates or the mappings of these 2 points. Now, if we look at the difference between the x coordinates and the y coordinates, we will find out what this particular mapping is and what transformation we're actually doing. There are 3 different types of transformations that we will be working with over the next several days. Today, you're going to get a look at a couple of them. The first one here is what we're doing called a slide. In order to figure out what type of mapping this is, we'd actually have to figure out, well, if I'm at 2 and I want to get to -5, what do I have to do to this number to make it become -5? And that should be pretty simple. I'm going to have to go far to the left 7 spots. So that is going to be x minus 7. And then for y, you want to do the same thing, except this time you're actually losing as well. So it's going to be y minus 3. So this will be our mapping. And if you look at every single point from the pre-image, say B to B prime, that's the same mapping that's going to happen. Same thing from C to C prime and D to D prime. And you'll be working on doing this week. Thinking about this in a larger picture, this is how distance is preserved between every point. So here's example 1. Does the transformation below appear to be a rigid motion? Explain. So what do you think? Look at the figures. Distance is preserved, but they're not congruent. So the answer is no. Question number 2. Does this transformation below appear to be a rigid motion, and why? This one is like the first example that you had. Distance is preserved. If you look at B prime to B, A to A prime, and C to C prime. And it also looks as if the figures are congruent. All right, so here's a secret hot question. What properties of a figure are preserved if it is a rigid motion transformation? Make sure you answer the hot question, and if you have not done your corrections, please do them and enter them into the quiz corrector. See you in class.